So, good evening. Thank you for coming. We are the National Middle Level Science Teachers Association. We are the only national association for middle level science teachers specifically. We're celebrating our 35th anniversary this year, and we make these webinars available to anyone. We put the recordings on our webpage for members. I hope you're okay with that. And as far as the NMLSTA is concerned, we offer cash awards a couple of times a year. We offer classroom teacher awards in the spring and the fall that will open up again soon. For the spring process, we offer an annual $1,000 HERD award for one person each year. And our website has resources, ideas of the month, these recordings, various other things available to our members. Also, we will make certificates available to anyone who wants one for participating this evening. I'll put my email in the chat so you can request one, and then I'll put it again towards the end as well as a reminder. Today we're hearing from the Science Department at the Science Education Department at the Center for Astrophysics, Harvard and Smithsonian. And our speakers are Philip Sadler, Cynthia Crockett, and Ting Reed, talking to us about revising and improving multiple choice questions with NGSS DCIs in mind. And with that, I'm going to turn the introduction over to them because they will do a much better job of introducing themselves than I possibly can. Thank you for coming.
Oops. Okay. Thank you very much, Anne. And thank you to all of you for being here. Welcome everyone to our webinar tonight on revising and improving multiple choice questions, keeping in mind the NGSS DCIs. And we're looking particularly at middle school physical science. And a huge thank you to NMLSTA for hosting us this evening. We really appreciate it. So here we go. So just a little bit about us. Dr. Phil Sadler is our department director and the PI of this project. Dr. Ting Reed is our postdoc fellow who's going to be doing the bulk of the analysis tonight. And my name is Cynthia Crockett. I am on the project staff. But I also want to acknowledge Dr. Sue Sunbury, who's here tonight. She's our project manager, and Dr. Gerhard Sonner, who should be joining shortly. He's our co-PI. So we are all, as Anne mentioned, part of the Science Education Department at the Harvard-Smithsonian Center for Astrophysics in Cambridge, Mass. So this project that we're going to talk to you about tonight and some of the results that we have is, we affectionately call it Construct. It's looking at developing assessments of physical science, middle school physical science through the disciplinary core ideas of the NGSS. And the goal of the project is to collaborate with teachers, classroom teachers, to develop and validate high quality middle school physical science, distractor driven. There has to be distractors in the questions, but they are largely multiple choice questions, assessment items, in order to answer a couple of questions in our project. And how we're doing this is we're partnering with educators, yourselves. We have employed crowdsourcing for pilot testing of these items. We have then gone to field testing with real students in real middle school science classes. And then we've done a lot of statistical analysis of these items. And all that is to be able to answer this of many questions. But can teachers, educators in the classroom, improve the items that were previously generated by content experts or others? And these items have been identified to have significant weaknesses. And that's what we're exploring tonight. And those are the results that we're going to be presenting tonight as to how educators can help us do this work. So the gist of the project, over the course of the last 2 years, we have an online free resource for science teachers. It's called Mozart, and it is K-12, all science areas, and there are multiple, I forget how many, multiple choice assessment items that are all steeped in research based on students' misconceptions that are free to use. You can download them. So that is our test bank that we are starting with. We chose 110 items from that Mozart test bank, and those were reviewed and 60 of them were selected to be revised as having issues. We asked for participation of educators, and what we asked for them to do was to either write new questions or submit their own questions that they already use for us to look at, and also help us revise these existing questions from our Mozart inventory. And the goal was to fix any problems that these questions might have been identified with, such as it's either too difficult or too easy. It does not discriminate between high and low knowledge students. And there's a difference in performance between students of different genders or different racial and ethnic groups. So for example, this is one question we asked people to help us revise. And this item turned out it was way too difficult. Only 10% of the students answered it correctly. And the question, as you can see, imagine that a huge flat piece of ordinary glass were placed halfway between the sun and the earth. What do you think would happen to the average temperature of the earth? And the correct answer is A, there'd be no change. But the misconception is B, the temperature would steadily increase as long as the glass stayed in place. And that was the majority of the responses that kids chose, was the misconception. So it's a very difficult question, and we asked for their help in how do we modify this to make it a better question. Another example is this particular item is 11% more difficult for girls than boys. And again, you're in a completely dark room without lights or windows. Which object do you think, or objects do you think you'll be able to see? And the misconception is A, a cat's eyes. And our research shows that kids are under the impression that cat's eyes glow in the dark. And if you see a cat in the dark and the light happens to hit their eyes, it looks like it glows. It's not inherent. However, the correct answer is none of these will happen. There's no light, there's nothing you're going to see. So in the process of looking at this question, it was way more difficult for girls than for boys. And this is just another example of one of the questions the types of questions that we asked people to help us revise. So how did we do this? So first of all, we created a pilot test, and we took 200 of these revised items. 50 of them were original items, and we tested them. We had approximately 760 plus test takers on a crowdsourced platform, much like Amazon Mechanical Turk. This one happened to be through Cint and Lucid. We had an average of 137 testers answer each and every question, and then conducted a lot of classical analysis to choose items for the field test. And there were 3 versions of every item, each item on the field test. We had the original, we had a revision that did not show any improvement, and we had any revisions that did show improvement. And from that, we created the field test. And the field test went to students in grades 5 through 9. There were 5 different test forms, 30 questions each. There was gender diversity and Hispanic and non-Hispanic populations across the field test venues. 124 educators participated, with almost 5,000 students participating in our field test. So the upshot is an average of over 1,000 students answered each and every question for us to be able to look at the data. And these tests were taken during regular class time. It was not a special testing session or anything like that, not like the NAEP or your state tests or anything like that, regular class time. And this just gives you a snapshot of the breadth across the nation of schools that helped us out with this. And you can see that we pretty much covered the entire nation. We have a little trouble getting North and South Dakota and Montana sometimes, but we pretty much have a good spread across the entire country. So that's what the gist of the project was for the last couple of years, trying to do this. And this is the territory we covered. And with that, I'm going to hand it over to Dr. Ting Ting Reed to go through all this analysis that we conducted on these tests.
Okay, thank you, Cindy. Hi, good evening. So I'll be walking you through the data analysis and results section. So first of all, I will show a few sample teacher submitted revisions to the problematic questions that we identified. So the first question we have here is, which of the following would a scientist say is the most pure substance? Lead fission weight, bottled water, stainless steel wire, soap powder, orange juice. So here we're looking at 5 indicators. So in terms of the p-value, that's the difficulty So 0.13, that means 13% of the kids got this question right. The D value means the discrimination parameter in our model, which means whether an item can discriminate between students who do the test well versus who do the test poorly. So the higher the better. And in terms of the MS, that stands for the misconception strength. So as Cindy just mentioned, so there's a single popular, distractor. So the most popular wrong choice that the kids chose for this question is B, bottled water. So 45% of the kids chose this wrong answer. In terms of gender bias and racial bias, we're hoping to see the values as close as to 0. So for this particular question, it's not as big of a concern to us. So that's why we ask the teacher to focus on the difficulty and discrimination parameter. Okay, next slide, please. So just to illustrate our results, so we plotted the item difficulty and the item discrimination on the in this 2-dimensional coordinate plane. So here on the x-axis is the difficulty, the larger is easier. On the y is the discrimination, so the larger is better. So here the red triangle dot just indicates the location of the original item that we just looked at. Next slide, please. So here you can see this teacher revised question. So the changes this teacher made are highlighted in red. Materials are made of substances. Substances can be just one type of element or compound, or they can be mixtures. So this teacher didn't do anything other than the stem of the question. And then in looking at the position of this dot, represented by the blue dot in this chart, we can see it has moved to the right and also moved, up relative to the original question. So that means it got easier and also more discriminating, which is great, something we're hoping to see. Okay, and so let's look at this teacher. So which substance would a scientist say is the most pure? In addition, she add the definition or the explanation for substance, matter that cannot be broken down further into other elements. In addition to that, she also changed the answer B from bottled water to plastic. So interestingly, we see that the misconception, the most popular choice, stays, changed to C, stainless steel wire. But regardless, this item is also, if the revision is successful, because it got easier and also more discriminating. Okay. So we have another teacher here. So she also, in addition to the change she made in answer B from bottled water to plastic ice cream container. So again, we see that the most popular choice, again, stainless steel wire. But in addition, she gave some examples, specific examples of the substance like oxygen, water, copper, and hydrogen. And it turned out this is even better because it makes the item much easier, and also more discriminating relative to the original ones, and also to the previous 2 items. Okay, so we have one more teacher, I believe. So this teacher, she didn't do anything to the question, itself, but instead, again, she also changed the bottled water to the seawater. So now answer B is the most popular wrong choice. So we can see this item compared to the original item, again, is much easier and also much more discriminating. So altogether, we can see these 4 teacher attempts are pretty successful, at improving the difficulty and discrimination.
Okay. Can I say a few words about this?
Yes.
Let's go back to that graph. Okay, so I've been a middle school teacher in a past life, and I was always writing tests and quizzes. And what do I take from this little experiment with these original question and these 4 changes? Well, it looks like the original one, where it says bottled water, MS is 0.45, which means that 45% of the kids who chose a wrong answer chose this particular one, bottled water. And when you look at the other misconceptions, stainless steel wire is the wrong answer. Seawater is a wrong answer. You can see that kids are probably mixing up purity with sterility or some special nature to the item. I mean, bottled water is very interesting because there are no standards for bottled water, and bottled water is often less pure than the water that comes out of your tap. Stainless steel wire might be used in surgery or might be used in a clean room, but it's a mixture of a whole bunch of different things. And of course, seawater is a mixture of thousands of things. So the items got easier and they got more discriminating, which is a good thing. The kids who did well on the test tended to get this question right versus the kids who did poorly on the whole test tended to get it wrong. So the changes, if you look at what teachers tried to do, they tried to often change the STEM and to put more definition in there, like CN said matter that cannot be broken down further into other elements, and AB said examples of oxygen, water, copper, and hydrogen. That was somewhat helpful, but when you look at the RM, they didn't make those changes, and the item is pretty good. So the problem may not have been so much in the STEM as in the very strong misconception of bottled water. So changing bottled water to seawater made the question easier and more discriminating. So we often think that changing the STEM might be the improvement that we need in an item and add lots more words to make it more clear, but that's not necessarily the case. So this was a successful item. Thanks, Tintin.
Yeah. Okay, let's move on to the next example. So this question, in addition to the difficulty and discrimination, we also identify the issue of racial language bias. So here's a screenshot of what the question actually looks like. Sarah is sitting in her backyard, looking at a tree. With which of the following statements about how she's able to see a tree do you agree? So here are the 5 options. And then, basically it's about the mechanism of visual perception. So just looking at these different values, so we can see 46% of the students got this question right. And the discrimination parameter of 0.46 is okay. And then 33% of the kids chose a particular answer, I believe is C, as the most popular wrong choice. And then I want to focus on the last column, which is the racial bias. So this means this item is biased against the Black and Hispanic children. So they scored lower than their white and Asian students by 14%. And this is really problematic. And we asked 2 teachers to work on this question and trying to make it less biased and also less difficult and more discriminating. Next slide, please. So here I'm just, let's first take a look at the first attempt by teacher HJ. So we're gonna look at the specific changes this teacher made in a few slides, but let's just look at the results. So in comparison to the original item, this question actually got easier. So more kids got this question, 59% got them right. And then we see improvements in the discrimination too. And then in terms of the racial bias, it has lowered. It's been reduced by 4%. So we would say this attempt is pretty successful. That's a good news. Okay, next slide. So here we have a second teacher, KP, who is also trying to address the issue of bias. So again, we can see the bias actually has increased by 2%, unfortunately. And also, it got a bit more difficult because 43% of the kids, only 43% of the kids got this question right compared to the 46% for the original question. So, so is the discrimination value. It's a bit lower too. Okay, so looking at the specific changes the teachers made. Next slide, please. So wow, so this teachers actually made a bunch of changes in both the question stem and also in the different answers. So which statement and corresponding picture demonstrate the light patterns that allow her to see the tree? So although I'm not as experienced, I don't have much experience working as a science teacher like Phil, but my hypothesis is the corresponding picture is a cue. So cueing the students to look at those pictures we provided to help them better process the information for the question. So in addition, in the teacher made the changes in the answers. For example, in the correct answer, first light produced by the sun reaches the tree, then her eyes see the light reflected by the tree, allowing her to see the tree. So relative to the original item, we can see that the item is actually much easier now and also more discriminating. So this is great. Next slide, please.
So the racial discrimination went down, or the racial difference went down, but the discrimination, the quality of the item went up. And so I think in B, if you look at the answer B, B for the original was sort of shorthand. Light from the sun reaches the tree, and then her eye, and she sees the tree, rather than breaking it down in more clearly. First, light produced by the sun reaches the tree, then her eyes see the light reflected by the tree, allowing her to see the tree. So the thinking of this teacher was, let's clean up some of this language, and even though the answer is longer, it's clearer in the sequence of what's happening in the vision. Okay, so.
That's funny you mentioned the word sequence because that's what the teacher KP did. So she made the change, which statement correctly describes the sequence of Sarah's ability to see. And in addition, she also changed the correct answer, also actually all 5 answers, but let's look at the correct answer. First, light from the sun reaches the tree. Second, light wave reaches Sarah's eye. The tree is observable now. So what happened now is it's actually got a bit more difficult because it's moved to the left relative to the original item, and it's also a bit less discriminating. So this is not quite as successful as we're hoping to see. Any explanations, Phil?
Yeah, I think this, you know, when we teach about light, we like to talk about particles or waves. And here, rather than just talking about light, they introduce this new term of waves. And often people think, well, it's more exact because physicists talk about waves all the time. But in this case, it didn't help. It made the item harder and less discriminating. So including some sort of scientific term might not be particularly helpful. And then as far as language, like looking at the last item, first the light from the tree travels to Zara's eye. The tree is observable now is a very strange construction, indeed. And so as far as language, this is probably more difficult language for KP. But now that I'm looking at, you know, the inclusion of light waves, which science teachers like to talk about, is not helpful when talking about vision. Vision was understood very well before light was determined to have some wave properties.
Interesting. Okay, so can we move on to the next example? So this is our last example on difficulty discrimination. In addition, we're looking at gender bias. So the teacher are asked to make the item less difficult, more discriminating, and also reduce the gender bias. So a freezer is kept at 0 Fahrenheit. If you were to ask a scientist about the temperature of some ice cubes that have been in the freezer for a few weeks, you would be told that the temperature of the ice was, okay, the correct answer here is at 0 Fahrenheit because the ice lost heat until it reached the freezer's temperature. So when I first saw this question, I was always get tripped up because I'm used to the Celsius instead of the Fahrenheit. But anyway, so I think this question is getting at the thermal, equilibrium. So in terms of the p-value and d-value, we can see that only 32% of the kids got this one right, and the discrimination is not so great. And then in terms of the gender bias, we can see that it's actually biased against the girls. So girls score lower than the boys by 9%. And this is one of the reasons why we picked this question and asked the teachers to work on it. So the first attempt is by teacher RL. Again, so looking at these values, we found, okay, it's easier, but so about 3% more of the kids got this question right, but the discrimination not quite good. But we're happy to see the bias was reduced by 3%. So that's good news. Okay, next slide. Okay, I think that's the original question. Next slide, please. So here we have a second teacher, KM, and see, so she is able to make the items easier, so 38% versus 32%, and more discriminating, that's great. And then also she's also able to reduce the gender bias by 4%. So we can say this is pretty successful, so attempt. All right. Again, so we're looking at these items specifically in terms of the changes they make. So next slide. So the first attempt was again, the changes are in the red. So this teacher the language at 0 Fahrenheit, the same temperature of the freezer because the ice lost heat until it reached the freezer's temperature. So again, this question got easier, but not quite as discriminating as the original item because he moved downward a bit. And the next slide, please. So in comparison, we see that teacher KM changed the language in answer C. So she added the word energy and turned out that it's easier and also more discriminating. But both items were able to reduce the gender bias. Any explanations, Bill?
Yeah, well, I like these three attempts to improve the question. So here, KM added this scientific word energy, which did help some, compared to the original one, talking about heat energy. But I'd like to, I'm looking at the STEM right now. The STEM used to be in the past tense, and now it's in the present tense. And that may have made it more easy to understand because the scenario was you'd be told that the temperature of the ice was, or you'd be told in RL the temperature of the ice was, and now KM says the temperature of the ice cubes would now be. So it may be that putting the item in the present tense without using the past tense, this strange construction of the past tense, made the item both easier to understand, easier to do, and less complicated for students who were reading. So, and was this an improvement in the gender bias as well?
Yes,
It was. So
both were able to improve. Yeah.
Yeah. So we're looking at improvement for girls or for minorities or English as a second language student may come from more clarity because the clarity would improve for everybody. So I think that's the lesson I would get here, that the temperature of the ice cubes would now be, maybe if we constructed it and just said the temperature of the ice cubes now are, would be better than writing these things in the past tense. Okay.
Interesting. Okay, so for this portion of the presentation, I'm gonna walk you through the classical test theory analysis. So basically what that means is we're looking at the item characteristics in terms of the discrimination and difficulty for the entire item pool, of teacher revised items in relation to the original items. Okay, so the overarching goal was trying to see the extent to which teachers can improve these items. So here, again, on the x-axis, we have the difficulty for the original items plotted against the difficulty of the change items on the y-axis. And here, the diagonal line just split this coordinate pane into two, parts. So if the items fall above the line, they were easier. So that's good news. If it fall below the line, that's harder. Something that we're not happy to see. Okay, next slide, please. So imagine, so this is an item that falls on the diagonal line. That just means there's no improvement. So it did not make it easier or more difficult. Okay. Next slide. So here is the first set of items that the teachers were instructed to improve on the difficulty. So here we're happy to see that the majority of the items fall above the line. So that means the teachers were successful, at improving the item difficulty, making them easier. Okay, next slide, please. So we also fit the best fitting line to this set of items. And here we can see the best fitting line falls above the diagonal line. So suggesting there's a positive uniform effect of these attempts. Okay. Next slide. So here are the blue triangle dots represent the set of items that teachers were told to improve in other ways than item difficulty. So we can see that fewer items fall below the line than the first. Okay, and here the best fitting line actually crosses the diagonal line. And next slide, please. So looking at these items as a whole, so we can see these two groups of items. So as expected, the teachers were more successful at improving the item difficulty as instructed compared to the teachers who were told to improve in other ways. So this is great.
Yeah, so the way, whoops,
Mhm.
let's go back. So the way I interpret this is that this is item difficulty on the bottom line. So an item that's got an item difficulty of like 0.2, that means it's a really, really hard item. Only 20% of kids are getting it right. And just about any change in the item that teachers make tend to make it easier. But if an item is already moderately easy, say around 0.5, teachers who specifically tried to make it easier were successful, versus teachers who were trying to do something else with the item didn't change the easiness of the item. So this to me tells me that teachers are quite good at making items easier for students. So.
Okay. So in addition, we're looking at discrimination. So the same way we're plotting the discrimination for the original items against the change items. If the items fall above the line, that means it's more discriminating. So better discrimination, otherwise is worse discrimination. So here again, the first set of items are the teacher attempts, that were for teachers who are told to improve on the discrimination. So we're happy to see that most of the items actually fall above the line. So that means these teachers were able to make the items more discriminating. So they have better discrimination. So next we fit the best fitting line. Again, we're happy to see that the line falls above these diagonal line, suggesting the successful, effectiveness of these attempts. Next slide. In comparison, we have a set of items that are teachers were told to improve, other than discrimination. So, and next slide, please. So we fit the best fitting line, and again, this cross the diagonal line. And next slide. So looking at these items as a whole, the teachers who are told to improve on the discrimination did a much better job as expected than the teachers who are in the group told otherwise. Okay.
Yeah, so teachers are very, I would say teachers are very successful at improving the discrimination, making the items clearer, when that's what they were trying to do. So it's very impressive to see this. I think it's at the level of experts who are editing items for national tests and state tests. Teachers know how to make items easier, and they know how to make them more discriminating, clearer, and so that students who have the right answer actually have the right idea, get the right answer. So great.
Yeah. So the next, we're looking at teachers' efforts in reducing the biases. So let's first look at the gender bias. So here, instead of the difficulty we're looking at the difference in difficulty. So what we did was trying to subtract, the difficulty of females from the difficulty of males. So then we get this difference, scores for the original items versus the changed items. So this is kind of opposite to what we're looking at previously. So here we're hoping to see the items falling below the diagonal line. So that means the improvements are successful. So these items are less biased, against females. Otherwise, it's worse for females. Okay, so here's an example. So this is a different score of 0.02. So, and it falls on the diagonal line. So that means there's no change. There's no improvement on the gender bias. In other words, the bias remains the same, Okay, next slide. And here, the first set of items are the teacher trying to improve or reduce the gender bias. So happily, we saw that most of the items fall below the line. So that means teachers were able to lower the bias for girls. And okay, and next slide, please. So in comparison, these are the set of items that teachers were told to improve in other ways. So the pattern is not quite clear, they're all over, and some are successful, some are not. So let's look at them all together. Next slide, please. Okay, next slide. So we looking at these two best fitting line again, even though, both cross the diagonal line, but we have some evidence to say that the teachers were, somewhat more successful at reducing the gender bias when they were told to do so than the teachers who were told otherwise. Okay.
Mm-hmm.
So last, we're looking at whether teachers are successful in reducing the bias against Hispanic and Black kids. Okay. So similar to the gender bias, we're hoping to see the items, falling below the line. So that means the teachers were able to reduce the bias for the Hispanic and Black kids. Otherwise, if they fall above the line, so that means it's more biased, against, which is worse for the Hispanic and Black kids. So in terms of the first group, that's the group of items that teachers were told to target or focus on reducing the bias for Hispanic and Black kids. And again, we don't see a clear pattern. So, it's like half of them seem successful, half of them seem not so successful. They're split. Okay. Then we fit the regression line and then next slide. So again, here are the set of items that teacher were told to improve other than the racial bias. So again, we didn't really see most of the items falling below the line as we were hoping to see. So next slide. Okay, so altogether, countering to our expectation somewhat that the teachers in the other group who were told otherwise seem to do a better job than the teachers who were told to reduce the racial bias. So I guess it's more difficult for a teacher to address this issue than the gender bias. Anything you would like to add?
Yeah, I would say what the conclusions for bias, and it's not really worse for groups, it's just harder for some groups or easier for other groups. That improving, trying to directly improve items and correct deficiencies for females or for underrepresented groups does not seem to be a strategy that teachers can actually affect. They can't. We don't see evidence that they can improve items in that way. We do see evidence that they can improve items with regard to difficulty and quality, discrimination. And that is probably the best that we can do. So focusing on making items easier and clearer is a much better strategy than trying to make an item less biased for females or males or less biased for particular racial or ethnic groups. So much better to make items easier and clearer, and that helps everybody. Okay.
Great, thanks. That's an excellent conclusion slide. So in conclusion, we're saying that teachers were more successful at improving questions to make them less difficult or more easier, improving discrimination value of the questions in terms of D. It's indicative of how well the test takers' responses to the item reflected their overall performance on the test. And last, we did see some evidence of teachers, ability to reduce the gender bias. However, did not see much evidence in terms of reducing racial bias for the Hispanic and Black kids. So I guess I'm going to turn this over to Cindy or Phil to talk about the next step.
Yeah, so Phil, I'm going to ask you to jump in here as well. So the next step is how you as educators can continue to help us, and we'd love it if you did. We are inviting middle school physical science educators to collaborate with us in the next phase of this work. We're actually very interested in the assessment questions and tests that you use with your students, your actual tests and questions, and we invite you to share those, share your experience with assessment items, as well as share the particular tests or items that you use with your students. And we're particularly interested in multiple choice questions. And Phil, I don't know if you want to elaborate on that.
Yeah, no, that's good. That's good.
Yeah. I'm stuck. So specifically, we're interested in how do you actually select your questions that you use, or how do you write them? Do you reuse them from year to year? Do you modify them based on, the class you're seeing currently? Where do teachers get their questions? Are they coming right from your textbooks? There's a multitude of online resources now. Do you write them yourself, etc.? And then also, what kinds of multiple choice test questions are you using in your assessments? So we're very interested in those parameters of assessment questions. So our hypotheses is, we have several, Items in textbooks have usually been subject to any analysis. They perform less well than those for which psychometric characteristics have been measured, such as what Ting Ting just went through. Also, that since teachers are making up or selecting test questions from textbooks, they're more discerning concerning what is a better question. And then also more experienced teachers are possibly better at discerning which assessment questions are better than others.
Mhm.
And we're interested in any other hypotheses that you may have.
Yeah, I think there's a word missing in that first statement. Items in textbooks have usually not been subject to any analysis.
I think you might be right.
Yeah, so textbooks are, they often hire people to write tests and quizzes for textbooks, but they don't actually give those questions to students to see whether they're hard or easy or discriminating, what the quality of those items are. So we're interested in comparing the work that teachers do to what's actually in the textbooks. And second, I think teachers can be very discriminating. They choose test questions from textbooks or other sites, online sites, and they choose ones that they like. And we're trying to measure and see whether the questions that teachers choose do they choose the better questions, and do more experienced teachers choose the better questions? So we're very interested in the quality of quizzes and tests that kids give in the classroom, and whether we can help teachers select or write better questions. But we want a baseline of what do teachers do now, and we have an opportunity for teachers to send us questions for which we will send you an honorarium. So do you have, oh, here it is here.
Yep.
So Cindy is about to say that if you contact her, she'll send you a brief survey, and then you can just take a scan or take a picture of one of your multiple choice test questions or tests on your iPhone and submit it to us. And as a thank you, we'll send you a Amazon gift card for participating in our study.
Yeah, and it's as simple as that. If you contact me at that email, I will send you the link, and we just ask you for a brief survey, just telling us a little bit about yourselves. And then it's very simple. There's a link, or you can just upload your test questions or your assessment, or you can take a picture of it and scan that and upload it, and I'll upload it and then transpose those into our database, and then we will put you in the system to have that $50 Amazon gift card sent to you. And we would truly appreciate any input that people have.
Yeah, so this is, I think we can open for questions, but what I wanted to say is that we're very interested in the tests and quizzes that teachers use. They spend about 20% of their time writing tests and quizzes and correcting them. So we think it's really important that they have really good questions that actually assess their students' understanding. So can we open for questions now?
We can, and just a thank you to everybody for participating or for attending this evening. If you do have more questions about the data, you can contact Ting Ting at that email. And if you would like to participate and you're up for the link I can send you, you can contact me at that email. So I will stop sharing and we can open it up for questions.
Do we have any questions in the chat?
We've kind of been lots of comments about question writing and STEM length and using terms that are either colloquial or not familiar to students. So we've been kind of going back and forth that you'll like to note, Phil, that was it Dave who remembers a private universe.
So when I didn't have any gray hair,
yeah.
That was at the beginning of my teaching career. That was really, really eye-opening, those videos. I think it was shown to me by a professional development person. And for those of you in the audience who are not familiar with those videos, they interviewed Harvard graduates and asking them questions like, what causes the different phases of the moon and why is it warmer in the summer versus the winter? And the majority of these Harvard graduates from many different majors got them wrong. And they were very intelligent students with
Yeah.
excellent educational backgrounds, and they just totally missed it. And it was kind of an introduction to, revising the whole way we're teaching science in the country. And I think it was heading towards some of the revisions to the science standards.
Yeah, well, thank you. You'd like to know that I just showed one of them in my Harvard undergraduate class on where do trees get their mass, and they were very impressed. Of course, the students in the video, these students weren't born when those videos were made, but they were very impressed by them. And their homework assignment was to go out and interview somebody using the same technique about where the mass of a tree comes from. And lots of students used Zoom and interviewed their little brothers and sisters to find out what they knew about what trees are made out of. So it was very cute. So thank you. I also see that the lead and fishing equipment may not be familiar to a lot of modern students, to a lot of urban students particularly. We didn't think about that, but that may be a reason that the item is hard. Let's see, any other questions from people?
I have one. When you were the instructions that teachers received to improve questions, either for discrimination or reducing bias, were the instructions similar for both tasks? Because I feel like when I was looking at those, I was having a hard time figuring out where the gender bias would come from. And also, I think that white teachers, for example, would have a hard time identifying what was hard to do, what was unfamiliar for a Black student, etc. So were the instructions familiar?
So Cindy, I can start and then you can jump in if you want. The guidelines that we put together, actually, we talked about each different type of, if you're doing it for difficulty, this is the kind of thing you may think about, and gave some examples. If you're doing discrimination, because they didn't, different questions had different problems. So if you're working with a discrimination problem, this is the kind of thing you might want to change. So we kind of gave them overall writing guidelines, good guidelines, like you all were saying, don't make those stems so long, and don't make the right answer be the long one and everything else is short. All those tricks of the trade that you all know. But we also gave them for each section if you're doing gender. And again, very difficult if you're not part of the population to do that.
Yeah, and that's a really good point, Sue. And we did, as Sue said, everybody got a detailed, set of guidelines of if you're working on this kind of question, here's the things to consider. But in terms of recognizing a discrimination, a bias that is not, maybe in your wheelhouse. And I had direct experience with this. We did the NMLSTA Share-a-thon in Denver, and had people look at some of these questions and then identify, the problem with the question. And one of them was a racial and ethnic bias. And, we had the question out there and people could read through it and look at it. And, the woman who I was talking with at the same time, and I knew her, she said, Cindy, I am a Black woman and I do not see any bias in that question. And which was really interesting. And to a person, everybody said the same thing. We don't see the bias there. Where's the bias? Well, the bias is in the numbers. Bias is in the statistics. But it was the question talking about Zara looking, being able to see the tree. And not one person said, well, think about the name you chose. Maybe you should change the name. That sort of has an ethnic inflection to it. And not one person identified that, but multiple people who were, people of color, flat out said, I am a person of color and I don't see any problem with that question. So it's difficult. It's not easy, but you know, you can give all the guidelines you want, but you have to, you're right, not everybody can see the bias if they're not in those particular shoes, or sometimes even if they are in those shoes, it's not, you know, it's not evident. So it's
Yeah,
difficult.
I mean, I take from this with, you know, the best we can probably do is just to make the items, you know, a little bit easier and increase the statistical discrimination, which is not racial discrimination or gender discrimination. It's increase the quality of the item to make it more clear. And that helps everybody. And we don't know how to improve it as far as gender or race. We don't know how to do that very well. And teachers don't seem to know how to do that either. It's a very hard thing.
I had a Korean student last year get stuck on, he was doing physical and chemical changes, and there was a question about a marshmallow burning.
Mm.
And he was hung up on the marshmallow, and burning would be a chemical change, but he was too hung up on the marshmallow to interpret the question.
Yeah, like the marshmallow test, right? For the 5-year-olds. Let's see, I'm looking through to see if there are any other questions or comments in the chat.
And if anybody has a question, please feel free to just unmute and fire away.
Yeah, I would say that long, you know, we try not to make the correct answer the longest answer or the one with all the jargon in it. That's, but that doesn't always, you can't always do that for every single question.
There are also kids who look for patterns in the answers. Well, this says A and B, so C is going to be next, or I've had a bunch of C's, so it's going to be something else. And writing test questions, I try really hard to not make a pattern, but then if I change the sequence, so I have an alternate test or something, I lose all that. And there are kids who get hung up on that, and you have to tell them over and over, don't do that. That's not what we were thinking, but that's the thing that messes too.
So any other questions? Well, maybe I can ask one. Where do you get the items that you use on tests and quizzes? Where's your favorite source?
I write mine.
You write them. Yeah.
Because I never found good ones otherwise.
Yeah. Anybody else?
Oh, there we go in the chat.
AAAS, yes. Good resource.
AAAS has some very good questions. They do.
Is anybody using AI to write your test questions? Yeah.
We have just started to experiment with that, and we find that we think that well, my experience with AI is it can write test questions, but then you have to go back in and say, I don't like that. You know, you don't have a misconception in there. It's you've got the wrong point. The stem is too long. You have to go in and keep modifying it until it produces something that's reasonable. It doesn't know what a really good question looks like. So it needs several prompts to get to a good place.
Interesting.
Yeah.
Very interesting. And good comments in the chat too.
And sometimes it's wrong. My colleague Gerhard Sonnet is watching this. I introduced him to ChatGPT and asked ChatGPT, he had never used it before, to tell me about Gerhard Sonnet. And it went through all of his early background, and then it started hallucinating his degrees and where he's been teaching. And finally it said, sadly, he died in 2018. So
He's on tonight.
I'm living on borrowed time.
yes. So ChatGPT does not always get everything right. It's like a good student, but not a great student.
Did you see that in the chat too? Somebody has tried it and it was bad at writing
Yes.
questions.
Yes, good, excellent point, Brenda, yeah.
Yeah, so I think it needs help, and Gerhard and I are very interested in the kinds of help that the ChatGPT needs to write better questions. So does anybody want to get $50 for sending in one of their tests?
Especially
Anybody?
those
Oh, we
of
got a
you,
few.
everybody's welcome, but especially those
Yes.
of you who write your own questions. We would love to see those.
Yeah.
I can do that.
So-
Your comment is interesting as well. AI can figure out, oh, that's an interesting, uses it for patterns. I'm going to thank everybody for coming. We're just past 8 o'clock. I'm going to thank
Yes, we are.
everybody. Remind you that we are the NMLSTA, the National Middle Level Science Teachers Association. Remind you, I put this in the chat a little while ago. If you want a certificate, please let me know. Email me. If you don't have my email, if you missed that message, if you lose it, Mary Lou, you can reach Mary Lou and she will send your name back to me.
Very good. And thank you to all of you for attending tonight. And thank you very much to Mary Lou and Anne for hosting us. And we look forward to hearing from some of you.
Okay, and Dave put a question there as well.
Absolutely okay to put this session on YouTube, yes.
I'm worried about how it
I'm-
recorded. Wanted it to record and it did the otter thing and I don't know which I'm gonna get, so we'll see.
Okay.
I'm hoping
we'll
it
find out.
recorded because I missed almost half of it. I'm so sorry.
At least you finally got your computer to cooperate.
Well, no, I had to open my laptop.
Okay. Well, thank you, everybody, and feel
This
free
is
to
a brand new
contact us.
computer.
Okay. Thank you all.
Thank
Thank
you.
you so much.
Thanks so much.
Bye-bye.
Bye.
Bye-bye.
Great.